All right, so to get started here, we're going to take a look at how to use something called generics in TypeScript. Now, as you'll see, the purpose of generics is to allow us to create things like classes and functions that work with multiple types of data, but also keep that data consistent within the function or class. Now, that might sound a little bit confusing, so what we're going to do here is we're going to take a look at a simple example. So what I'm going to do is I'm just going to create a new file, which we'll call something like generics.ts. Now, let's imagine that we want to use TypeScript to create some sort of class representing a data structure, right? This is generally where you'll find things like generics used. So let's say that we want to create a simple data structure like a queue. Now, in case you're not familiar with what a queue is sort of like an array, but its specific purpose is to allow us to add items to it and remove the first item in the queue, right? Sort of like if you picture a line of people waiting to check out at the supermarket or waiting to get on a ride at an amusement park, right? The people who are joining that line get in the back of the line, and then the people in the front of the line are the ones that are actually served. So, this is used in a variety of situations. If you have, let's say, a list of tasks that your program has to run, then, that's where you might find queues used. So let's start off here by creating a queue, and what you'll very quickly see is that we're sort of forced to choose a data type that this queue is going to work with, right? So in other words, do we want this to be a queue of strings? Do we want to add numbers to the queue? Do we want to add objects to the queue? We're forced to kind of choose in the implementation. So just to show you what I mean here, let's say class queue. And what we're going to do here is we're going to create an instance variable called something like items. And this will just be an array of the items that the queue contains. Now, again, this is where we kind of have to select the data type that we want to choose, because we don't want this queue to just be able to contain any type of data. And if we were to just assign the type any to this items array, or it would be any with square brackets after it, then the problem with that is the data in the queue wouldn't be a consistent type, right? In other words, the client code that used this queue would be able to add a number and then a string to the same queue, which is something that we would probably want to avoid. All right, so in this case, we would have to sort of choose if we want to allow users to add strings to the queue or add numbers to the queue. But the problem with that would be that we'd really be restricting what sorts of situations this queue could be used for, right? So if we were to choose, let's say, strings, then what we'd have to do is we'd have to add a constructor here that would initialize this.items to an empty array. And then we'd have two methods here, one for adding items to the queue. So we'd say add, we'll just call the method add here. And again, for the argument here, this argument would have to have the type of string as well, right? Because this would have to match the type of the array in order for items.push to work, right? And oops, we'd have to say this.items.push for that. All right, and likewise for a method that would remove elements from the front of the queue, what we would have to do is we would have to say remove, and what this would do is it would return a string, right? It would return the first string in the array here. So what we would do is we would say return this.items.shift. All right, and the shift method here, in case you're not familiar with it, just removes the first element from a JavaScript array, or TypeScript array in this case, and moves everything over to the left one. So anyway, now that we have this, and by the way, you'll see this red underline because the shift method can actually return undefined as well if there's nothing left on the array. So we'd want to add that to the return type here by saying or undefined, right? And we are creating a union type there, remember? So anyway, that would be our queue class, and this would be great, except we come back to this problem of the fact that this specific queue class would only work with strings. So in other words, if we wanted this same class to work with numbers, we'd have to create a whole other class called something like number queue. And then we basically just have to copy all of this implementation code in our regular string queue class and just go through and change the types to number instead of string, right? So we'd have to say number array. Then for add new item, we'd have to say that that is a number. And for remove, we'd have to say that that is a number as well. Okay, and then, if we wanted this to work with some sort of custom type that we created, such as our person type that we declared previously, right, this one here, we'd have to make yet another class called something like personQ that is, again, basically the same thing, but with our person type substituted for number and string. Now, this obviously is not a sustainable solution because at some point we're just going to have so many different queues that when we want to modify the behavior of our queues in some way, we would have to make that same change across all of the different queue classes that we created. So anyway, all of this is setting us up to demonstrate how useful generic types can be in TypeScript, because basically what generic types allow us to do is treat the type that's in something like a class or a function in a similar way to how we treat arguments in a function, where, in other words, we're able to pass that in to specify what type we want. Now, in the case of this queue class that we created, here's what a generic type would look like. First of all, the way that we tell TypeScript that we want a class or a function to be generic is after the name of that class or function, we use triangle braces, and inside of there we pass some sort of name that TypeScript will then use to identify the type, right? So in other words, this is sort of the type equivalent of arguments in classes and functions. So now all we have to do is replace the hard-coded type names inside our class with that name that we gave to the generic type, right? So we replace string with t, we'll do that here as well, and we'll do that here as well. And that's really all that we would have to do, because now this queue can be used with any of those types while still only having a single class. So in other words, what that would look like now, if we wanted to use this, is we could create a queue of strings by saying let string q equals new queue. And here's where we tell TypeScript what type of data we want this specific queue instance to contain. In triangle braces, we would pass the type name string, right? So this would define a string queue. And then we could say string queue dot add. And if we wanted to add a string onto there, we could say hello. And then we could say console.log, and then something like the first element in the queue is, and then we could say string queue, there we go, dot remove. And that would take the first element off of the string queue and print it to the console. Okay, now again, with this string queue thing here, notice that if we try and say string queue dot add and add any other type, such as a number, that's going to give us an error. And that's the difference between using a generic type like we did here and the sort of lame shortcut way of just using the any type, is if we had just used any, this wouldn't give us an error. But since we've used a generic type, TypeScript is going to force us now to be consistent with our typing in this specific instance. And if we wanted to create now another instance, but with a different type, right, such as a number queue, then what we could do is just say new queue, and in between those triangle brackets, we would now pass the number type instead. And then we could say number queue dot add, and we could add numbers to this now. And again, just to demonstrate that if we try and add a string or any other type, right, we'll say hello. TypeScript is going to give us an error with that because the number queue is only meant to work with numbers, which is what we've told TypeScript by passing number as the generic type. Now, in case you're wondering, generics can work with just simple functions as well, right? So if we wanted to define a function called something like print, and we wanted this to be able to print out any data type that we wanted, then we could just say print, and then the argument that this would take would be of type t, right? So we could just say value t, and then the return type of this would just be void, right? So, oops, I don't want that all in caps, there we go. And then inside here, we could just say something like the value is, and then we could print out value. And this would work with pretty much any type here. So if we wanted to call that now, we could just say print and pass a value to it. And notice here too that TypeScript can automatically infer the generic type of this function in this case just from the argument, right? Because the argument is type T. When TypeScript sees that, it's going to realize, okay, that's the type of data that we're dealing with. And all right, and that would be the same kind of thing here as if we were to allow users to pass in some sort of starting value for our queue, right? We could say starting value, and that could be of type T, and that would be the first value that we would put into the items array. Oops, that wouldn't be T, that would be starting value. So in this case, right, if we were to pass a starting value into the queue, we would no longer need that generic type because TypeScript would be able to infer just from that argument what the generic type would be, right? You can hover over string queue and you can see that it still realizes that this is a queue of strings because we passed a string into the constructor. And the same thing for the number here. If we were to just start this off with a number and remove the generic type, TypeScript can still tell that that's a queue of numbers just by looking at the type of that argument. So if we hover over number queue, we'll see that sure enough, that's a queue of numbers as well. All right, so hopefully this has given you a good introduction to how generics work in TypeScript. This is probably something that you'll see from time to time throughout the rest of the course, and it's definitely something that you'll see in real-world code just because it's such a useful thing for allowing us to define classes that work with multiple types while still retaining type consistency.